Hey everybody, John Harper, founder of Hackers Teaching Hackers, back with you again on another HTH CTF 2024 challenge. This time we're going to be looking at Whipped-in-War. So Whipped-in-War was worth 200 points. It had one solve. Again, I think this is one where we released it kind of late in the CTF, but definitely worth looking at. I think this one's worth looking at because we've done a similar thing in years past. In fact, Whip It Good actually is kind of the one we did last year. And then I kind of took some of the same tactics and moved it forward into Whipped-in-War this year. So you're going to see that one potentially in the future, some parts and pieces of it. So this is definitely worth kind of walking through. So when you go into Whipped-in-War, you'll download a war file. And once you have the war file, you'll just be able to extract it. So war is just essentially an archive, right? Again, me trying to use obscure archive files. So you can just extract here. And there we go. So whipped in extracts, and you get three files. I'll go ahead and move into that folder. Cool. And, from here we see that there is like what looks like some C code. We could open that up with a text editor. In here, it looks like it is an encrypt or decrypt uh, Terminator OS file tool of some kind. So that's cool. So it's definitely some C code. You know, may or may not need to do anything with that. There's another file here, Terminator can see, and oh man, yeah, just like a bunch of stuffs in here. Again, this looks like C code for sure. It's C code. Yep, definitely. A lot of it, in fact. And then we have Terminator OS bin. So let's see what's in there. So yeah, this is definitely a binary file. You'll notice if you have like a compiled ELF or something like that, it usually looks like this if you're trying to open it in a text editor. Cool. All right. So what do we want to do here? Well, this is definitely C code, so we could just rename that in here. This is just play on words potentially. So we'll just go ahead and do that. Um, we can actually go ahead and compile these and just see what we can do with them, right? So let's go ahead and do a GCC and then do a -o, and then we'll do that tool and that tool C. Cool. All right, so it compiled successfully. So that's cool. Looks like we have the binary here. We can do a chmod plus X on the tool. And we could run it and just see what it does. Oh, encrypt or decrypt. Okay. Well, I guess I want to decrypt maybe, or I don't know. Let's see. Oh, input a file name. Um, okay. We could do maybe that Terminator OS. I don't know. Here, output file name test. Oh, I need a key. Okay. I don't know what the key is. So just whatever. So it generated something to file, and if I open that up in an editor, nope, it's just more junk. So I need the key for sure. So let's move that to trash. And then let's go ahead and GCC compile that other one. Nader can see. Cool. All right. And once I've compiled these, I probably don't need these anymore unless I needed to modify anything in here, which you never know. Maybe that might be something fun to do in the future. But let's go ahead and just chmod, then Terminator can see, Terminator can rather, and then go ahead and run Terminator can. Oh, interesting. Okay, so the key is deep in the Terminator's memory. Interesting. And I have a message here, and it looks like it's base 64 stuff. When I try and copy this, you know, I could try and maybe, drop that to a file or something like that, and maybe base 64 decode it. But I'm going to go and tell you actually, the hint is right there in memory. So this is a utility in Linux called Whiptail, and Whiptail allows you to put up messages essentially like this. So the best thing to do if the message doesn't fit in a Whiptail screen is to, and again, sorry, my hotkeys don't work in here real well. So I'm gonna blow that up. Is to run a process check on it. So we could, you normally run like a PS, you'll see processes running, but it doesn't show all of them. If you do an AUX, it shows, or AXU is what it would show in man, but I don't know, just for me, my memory learns aux better than AXU. So, but it's the same thing. And essentially, it shows all the running process information when you do that. And then what I'm going to do is, that's super cheating. Just see what that command looks like. In here now, you're going to see that I ran this command, and there's the whiptail, and you can see that there's more information over here, and it kind of went off the page. So what I want to do is actually just isolate that one process. So if I do that, you'll see what I can do is I can actually grep for whiptail, which will match this line specifically, and we'll just dump the contents of all of this line into something dot text. All right. So we'll do that, and I'm going to move something dot text into that project area. Put it in whipped in too. Cool. All right. So I don't need this anymore. And I can close that whiptail. So here is something. If I open something, you'll see the entire message. So here was the first part of the message that we could see in Whiptail, and the rest of it got cut off. But now we can see all of the rest of the message. So if I take the rest of this junk that's in the front and take it off, and I go ahead and take everything that's in the front, kill all that. That is really just a base 64 that I think I probably need. We'll go and close that out. And then let's go ahead and just do a base 64 decode something and see what it is. And I'll jump or drop that into, I don't know, just call it S2, whatever. Who cares? All right, so let's cat S2. See what it is. Oh, okay. So that's hex right there. So it's definitely not a file type. This is just a hex dump. This is a hex dump format. So what we want to do is reverse the hex. So first it was base 64 encoded. Now we got a hex dump. So let's go ahead and cat S2 again. And this time let's use the utility XXD to reverse the hex. We don't need to do a PS in this. Let's just do a -R since it's in a hex dump format. And now what we have is a hex string, essentially, just a string of hex. So we do need to do another reverse apparently with XXD, but this time we need to do a -PS to reverse it back to plain text. All right, so let's do that. XXD -reverse PS. Let's see what we get here. Okay, cool. So by the way, this is a gotcha. If you don't recognize the hex formats and you just start willy-nilly throwing in like dash, PS and whatnot, that's where you can get stuck in a loop where it'll keep reversing a hex in a way that it'll just keep going. And you're like, why isn't that reversing? And it's because you're not paying attention to the formatting as it's doing that. So it's doing what it's supposed to do, and you're just not telling it the right thing. So you got to make sure that you, in this case, since it was a hex dump format, just to do a reverse, and since this is a long running string, we can do PS to uh, text. All right, so it looks like this is the key apparently, and that is T1000 screen overflow. So I'm going to go ahead and copy that. Let's go ahead and touch key. I'm just going to open this up and paste it in. Cool. So there's our key. Just going to save it in case I need it. That and cool. All right. So the only thing we haven't really messed with in here is I'm just going to go and clean this up. I'm going to move these C files out. Something was something we already reversed, so we don't need that anymore. We do need the key. We don't need S2 anymore. And we don't need Terminator can anymore. So we're down to dat tool and the key and the Terminator OS bin. And if you looked at the C code for dat tool, again, it did say it could decrypt the Terminator OS. So that was another hint to indicate that that's what this file is. Definitely, it's encrypted. So let's go ahead and run dat tool again. And we're going to go ahead and decrypt, input the file name. It's the Terminator os.bin. Cool. And then output file name, we'll just call it something. I don't really know what it is. And then we need to provide the key, which I'll go ahead and copy one more time just in case. Paste that in there. Cool. All right. So it completed and it output an image in this case. And it's an AI generated image of me with some Terminators back there. So that's fun. So typically when there's an image, you know, there may be a couple ways to embed things into it, right? So at that point, you may want to do like EXIF tool on something here. And we can see the comment Cyberdyne programmer was John Harper. So fun little comment, but nothing useful in here. Sometimes we'll hide flags in comments. And I didn't see anything in the image itself that said anything about a flag. There wasn't really any like sort of white space in the image where we could kind of change contrast necessarily, maybe. So I don't think that's it. So that might be a least significant bit kind of thing. So let's just go ahead and do a strings on something. And yeah, it is a least significant bit because you can see very clearly that there's some what looks like base 64 encoding here at the end. And I'll just go ahead and echo that. And base 64 decode it. And okay, so our flag format is in HTH within brackets. So if you were to count the letters on this, you would see that from H to U is exactly 13 characters. So, you kind of get good at recognizing these pretty quickly. So this is definitely ROT 13. ROT just stands for rotational, and 13 is, for some reason, we just picked 13 out of the hat. I think, I don't know, maybe there's some history there. I don't know. Someone can school me on that later, but essentially you can ROT anything. You could rotate 15. It's basically a shift cipher, essentially. So with this, what we could do is we could go into CyberChef. If you're not familiar with CyberChef, it's basically a pretty handy utility Let's see. Actually, I think I've already got one open here. Yeah, so CyberChef. This is the URL. Anyway, you can go in here and you can paste that string in here. And then let's click that recipe out. And then we could say, um, search for rot 13, drop that in there. And then you can see it's HTH frothy goodness is the flag, but it wouldn't be a teaching conference if I didn't show you how to do this in Linux as well. So let's show you how to do essentially a rot whatever you want via command line. So what we can do is we can actually just echo again that, so if you type echo, that string. And then what we'll do is we'll I already had it filled in, but anyway, we'll pipe it to TR, which is translate. Um, and what we do in the first set of quotes here is we give it what input we expect in from the string. So if it's an A, then we want to shift it with now an N, and we have to, the Linux is case sensitive, right? So if it's a capital A, shift it with a capital N. And why did I say go from A to N? Because N is 13 characters past A, if you count. And then we of course have the shortcut here where it's like anything in between A and Z, shift it between N and Z, and then pick up back at A again if it's because it's going to go past Z, and start over again with A and then go to M. Right. And then again, if you expect anything from lowercase a to Z, it's literally the same thing all over again. It only this time it's lowercase. So it looks complicated. It's actually really easy. We're just going from lowercase n to lowercase z. And if it goes past Z, we start at A again and go to lowercase m. So that's all there is to it. It's very easy. You can adjust this to be whatever you want to shift the cipher however many letters you decide to do. And by doing that, you get the exact same output, which is HTH frothy goodness. So that is how we solve Whipped-in-War. I hope that was another helpful video to learn some new tips and tricks. We'll catch you next time.